In this video, I will walk through an example of limiting reactant stoichiometry, which requires gas laws. So nitrogen monoxide and hydrogen gas react to form ammonia and water. And in this example, we're going to focus on how much ammonia can be produced. We're going to start with information about nitrogen monoxide that we can plug into a gas law to find the moles of nitrogen monoxide. And then we'll use the 2-to-2 ratio in the balanced chemical equation to find the moles of ammonia. In a similar fashion, we're going to start with some grams of hydrogen, use the molar mass to find the moles of hydrogen, use the information in the balanced equation, the fact that 5 moles of hydrogen are required every time 2 moles of ammonia are produced, to find the moles of ammonia that are produced. And when we see which reactant produces less ammonia, we'll use the molar mass of ammonia to find the theoretical amount of ammonia in grams that could be produced. For our first reactant, nitrogen monoxide, we're given information that we can plug into a gas law. PV equals nRT is the ideal gas law. We have the pressure, the volume, and the temperature. R is a known constant. We can solve for the number of moles. The known constant R is a number that in a different class you would memorize, but you definitely want to have handy as you prepare to take the test. So because R has units of atmospheres, our pressure has to be in atmospheres. Liters, our volume is in liters, but it was given in liters. Kelvin means our temperature needs to be converted to Kelvin. In gas law problems, temperatures must always be converted to the absolutes or the Kelvin scale. And once we have that information, plus we know R, we can solve for the moles. So I've rearranged, and I'm plugging in the values we know. Here's our pressure in atmospheres. And so the units of atmosphere will cancel. Here's our temperature in Kelvin. And so the units of Kelvin will cancel. Liters cancels, and we're left with 1 over 1 over moles. 1 over 1 over a number equals that number. And it works the same way for units. So I plug in my values and I get an answer. And the answer is good to 2 sig figs. But I'm not going to round yet. I'm going to keep all those digits. I'm going to use the ratios given in the balanced chemical equation to go from moles of reactant to moles of product. And now I'm going to look at the other reactant, hydrogen. We're starting with 1.2 grams of this diatomic element. I use the molar mass to go from grams to moles. I use the 5-to-2 relationship to go from moles of reactant to moles of product. And I come up with the moles of product. 2 sig figs. I have enough hydrogen gas to make 0.24 moles of ammonia, but I only have enough nitrogen monoxide to make 0.0613. So nitrogen monoxide is the limiting reactant. Hydrogen is in excess. I'm not going to use the information about how much product could be produced for hydrogen. I'm going to continue on from moles of ammonia that could be produced from our limiting reactant. I have 2 sig figs, so I'm limited to 2 sig figs in my answer. 1.0 grams of ammonia gas could be produced, in theory, given these starting amounts. Thank you for your time.